Hello everybody, it's Mr. Mulvihill. Hope you guys had a wonderful weekend. We're back here with this online learning. We are going to do another video today. So the key things for the video, pause it if it doesn't make sense, and ask questions if you need help. So here's the bell ringer, give that a shot. Pause the video because I'm going to show you the answers in 2 seconds. Alright, those are the answers to the bell ringer. You're doing the opposite. So if you're adding, you're subtracting, if you're multiplying, you're dividing to get your answers. All right, here we go. Last week, this is kind of the stuff that we did. We've been doing percent problems, and how we do it is we really just take the percent and times it by the original amount of something, and that will equal our new amount. That'll equal our new amount. So we're going to be doing the same kind of stuff today, except we're going to have to do one question a little bit differently. So let's look at the first one here and see if we have to do anything differently. Ellen buys a new bike that originally costs 80 bucks. However, since Ellen is an employee at the bike shop, the store sells it to her at 30% off. What will the new price be that Ellen has to pay? Well, from last week, we know that 30% off means that they're paying for 70%. And we know that 70% as a decimal is 0.7. And so now we can use this formula up here that you've been doing already. 0.7 times the original amount, so originally cost $80, and that is going to equal our final amount. So if you do that in your calculator, 0.7 times 80, you'll get $56 as your new amount. 30% off, 56 bucks, not bad. Now though, I want you to look at question 2. Give that a read and think to yourself what's different about that. Okay, so in this question, we know that it's 30% off the original price. And basically at the store shelf, like, oh, sale, it's 28 bucks. And we know that it was 30% off. But do we know what it originally costed to bring it down to 28? We don't. We don't know what it originally cost. This makes this question very different. All we know is that the $28 is 30% off the original price, whatever it was, right? So we also know then if it's 30% off the original price, then the opposite must be true. We must know that this is 70% of the original price. That is what we know. So let's use this formula because this is going backwards, this question. We know what the sale price is, and we're trying to bump it up to find what originally cost. So if we use our formula, the percent is going to be 0.70 for 70%. We don't know what the original amount is in black here. We don't know what the original amount is. So if you don't know what something is, like the bell ringer, you can call it X. Equals the new amount. This new amount right here. And the new amount, the new sale price is 28. And there we go. Now we have an equation that we can solve. So we're going to go ahead and solve this just like you would with the bell ringer. Divide by 0.7, and you should get x equals 50. Excuse me. X equals... You guys should have your calculator there. X equals 40. All right. Let's try another one here. A new softball glove costs $43.20, tax included. If an 8% tax was applied, what did the glove cost originally before tax? So this already has the tax built in. And there was an 8% on it. So you got to take a minute and pause and think about what that means. Okay, when you go to the register, you're paying for that amount. Cha-ching, you're paying for that amount. And that's with the tax. But when you went to the aisle, what was that price that was on the glove? Well, let's figure this out. So, if there was an 8% tax, that means that the new percent is 100% plus 8%. That will make 108%, and that'll be 1.08. So if we use our formula, the percent is in red, so 1.08 times the original, so we don't know what that is, so that's just going to be x, equals that new amount, which is 43.20, that's the amount we have to actually pay for, and then you're just going to go ahead and solve it. It's an equation. 1.08, divide both sides, you'll get x equals 40. So on the shelf, it really costs 40, but the government is going to make you pay 43.20. All right, what I want you to do, pause the video, try number 4 and 5. All right, guys, so here in this question, if you're thinking about it, what you basically have is Elena is going to give Jenna a soccer ball for $13. Elena had to pay more for that, though. When she was the first one, she bought it at the store. She had to pay 35% more than what Jenna's getting. So Jenna's getting 35% off, which really means that Jenna is paying for 100% minus 35%. Jenna is paying for 65% of the original cost. Elena knocked it down. Good friend. 35% off of what I paid for. And we know that 65% is really 0.65. So what we can do is, using our formula, 0.65 times the original. We don't know what Elena originally paid for. All we know is that she knocked it down 35%. We do know that when she knocked it down by 35%, it cost 13. So if you go ahead and now solve this equation, once you had the equation, you were so good to go. Divide by 0.65, x equals 20. So that's how much Elena had to pay in the store for it. A quick way to check is going backwards with your work. So if Elena had to pay $20 in the store for it, and she's going to knock off 35%, so 0.65, going backwards kind of, you could go in your calculator and see what that price will be, and you'll actually see that it's 13. So it matches the work that you did. All right, last one here, number 5. Cam goes to the store on his birthday because Foot Locker will give him 15% off a pair of new shoes. The shoes originally cost $40. How much will they cost now? Wait, they tell us in our equation here, percent times original equals new. They tell us what it originally cost. This is just pause. You know, not literally, but think, hey, we've been doing these questions a million times. 1,000,001 times now, because this percent off is just like those questions. That's really 85%, so 0.85 times the original $40. You take that amount, and it is going to be 34. That's the questions we've been doing. It's important to know the difference. Am I doing a different one where I got to go backwards like here? Or am I doing one that we've been doing? So pause the video if that doesn't make sense. Rewind it. Figure it out. I'll be available for questions. But if not, good luck on the assignment. It's due tomorrow night. Have a great rest of your day. Bye-bye.